So you're probably familiar with console.log and a few other console methods like error or maybe even table, but did you know there are over 20 different console methods and each one has their own unique use case? In this video, I'm going to be covering every single one of them, breaking them down into 4 separate categories, and all of this is to help you with your debugging, because if you can debug code better and quicker, it means that you can write better and quicker code. So let's get started now. Welcome back to Web Dev Simplified. My name's Kyle and my job is to simplify the web for you so you can start building your dream project sooner, and I'm going to help you do that by talking all about the different console methods. Now this is actually based on a blog article that I wrote recently covering all these different console methods. If you're interested, I'm going to link it down in the description so you can check it out. It's a really good quick reference for all the things we're going to talk about in this video. And if you want to get articles like this every week in your inbox, sign up for my newsletter. You can do that just at the very top of my blog. If you just scroll down a little bit, it'll show up for you. With that out of the way though, let's talk about the different console methods. Like I said, I'm going to break them down into 4 different categories. The first category is all about basic logging methods that all kind of work in the same way. Then we're going to move on to loggers that specifically deal with how you format code in the output. We also have loggers that deal with performance and making sure your code is running efficiently. And finally, I have a group for utility loggers, and these ones are just going to be different loggers that didn't fit in the other groups and are just helpful in general. So to get started, everybody knows console log. You just say console log, type out a message, and it's going to show up in your console output. That's super straightforward, but there's actually 5 different types of console log that all work exactly the same. So there's console log, there's going to be one called console.debug, and you'll notice something interesting. When I save it, doesn't even show up by default in the Chrome browser, and that's because you can change what level of logging you have here, and debug messages show up under this verbose section. So you need to have that checked, and now you can see we have that message showing up. We also have console.info. That's if you're going to have an info message. Again, we can toggle on or off if we want to show those logs. We also have console.warn. This is for a warning message. And then finally, we have console.error. And if we want to see what all those look like, I can just copy this code over. It has all 5 of these different loggers. And we click save. You can see we get all 5 of these being printed out. Now you're probably super familiar with console log, and the nice thing is that all 5 of these methods, console log, debug, info, warn, and error, they all have the exact same syntax, work exactly the same. The only difference is that they all print out to different logging levels. So for example, we can hide errors and warnings, or we could show only errors and warnings and not show these other log levels. This is useful if you want to make sure you kind of get rid of all the fluff and only show the important things. So depending on what you want, you can show these different log levels. They also have different appearance on the side. So as you can see, these warning and errors are a little bit more prominent. So that's really useful for doing different types of logging. And depending on what kind of log you're making, make sure you use these specific methods. Now, before we jump over to the really cool different formatting console log methods, I want to talk a little bit about some syntax related to these methods. And again, like I said, they all follow the same syntax, and it's important to know how it works. So first you can pass one value and it's going to log out just fine. What you can also do is you can pass multiple values, for example, like this, and they're just all going to print out. And you can do strings, numbers, you can do objects. It doesn't matter what you're printing out. It's just going to show up on the screen as you can see over here, and you can kind of inspect all these different elements. But something really interesting that a lot of people don't realize is that objects work a little bit interesting inside a console log. So let's come in here and we're going to create an object. We're going to call it person. We're just going to set it equal to this object here that has a name of Kyle. So we'll just copy that up. And what we're going to do is we're just going to log out person. Whoops. Person. There we go. And as you can see, it has this name Kyle. And when I expand it, you can see we get the detailed information about this person object. Now, what happens if instead what I do is I come in here and I change the person name to Sally. And then let's do a second console log of our person. So now you can see we have our name Kyle at the top and our name Sally here at the bottom. And when I expand Sally, you can see the name is Sally. But when I expand to this Kyle one at the top, you can see the name says Sally. Now, the reason this happens is called live view. And essentially what that means is that when you print something out to the console, it's going to give you essentially a preview of what that thing is. And then when you expand it, at least in the Chrome browser, then it's going to query whatever the current value for that person is. And that is going to be what it shows when you look at it in the console. So if we come in here instead and do a set timeout, and inside that set timeout, what we do is we change the person's name. And let's say we do it after 1 second. So now if I save expand to Kyle, you can see the value is correctly set to Kyle. And it doesn't matter how many times I open and close it, you can see it already queried what that value is, and it is Kyle, and this one is set to Sally. But if we try this again, and I wait until after the name is changed to Sally before I open Kyle, you can see it has that incorrect name. This is something that's nice if you want the most updated version of the object at all times, but more often than not, it's confusing because you want to see what the value of person is when you do the log, and you don't want to see what the value of it is in the future whenever you look at it. So a really easy way to get around this is to just come in here and do a clone. So by putting this triple dot right here, all I'm saying is clone this Kyle object. I'm cloning this person and I'm then turning it into a new object. So essentially I have the same object, I'm just cloning it. So that way, when I change the person in the future, it's changing a different object. It's not changing this new object. So if I save, I wait till Sally pops up and I expand Kyle, you can still see it has the correct name Kyle. Now this works great as long as you don't have nested things inside of here. For example, if I have a friends array, friends array, and we're just gonna set it to Joey inside of a string here. And then down here, what I'm going to just do is say person.friends.push John. Now, if I save this and I wait a little bit and I expand, you can see the friends array has the incorrect information. And that's because all this does is make a shallow copy of my person object. While if I just refresh this again and I expand it before I changed the person's array, you can see now it has the correct information inside of it. So to get around this problem, a really easy way is either create your own clone function, or what you can do is you can just do a JSON parse with a JSON stringify inside of it. And what you're essentially doing is you're just converting your person to a string and then converting it back to an object using JSON. And this is going to do a clone for you. So when I save here and I come over to my thing and I expand the array, you can see it only has the one friend, even though I changed that friend later. So understanding how this works and making sure you can work around it is a really important thing, especially when you're trying to debug complex problems, because if the values you're seeing in your logger are not the actual values from when you logged them, it can make debugging a nightmare. Now, if we just roll this back a little bit to just a normal string, let's say I wanted to log out a string followed by another string like that says hello like this. Well, what I could do is I could log that out like this and that works fine. But I could also use a %s symbol and then pass hello as the second property here. And what that's doing is it's saying, hey, replace this %s with the next thing that I pass to console.log. And the really interesting thing about this console.log is that you can use multiple different % symbols. They're essentially placeholders, and those placeholders are replaced by the next thing you pass in. If I come in here and I also say, let's say I want to get a number, I can use %i, and that allows me to use an integer. So I could just say 2, for example. And now you can see wherever I have %s, it's replaced by my first parameter. The second parameter %i is replaced by the second thing I pass after my main string. And you can do this for a large variety of things. For example, if I wanted a floating point number, I could use %f, and now I can put in a floating point number, and you can see it prints out. I can also do an object using O. So I can come in here and I can say, for example, name is Kyle. Save that, and now you can see it printed out that object. Now this is kind of cool, but honestly, I really never use this because instead you can just use string interpolation. So I could just come in here and I could say string, and then inside of here I could just put, for example, whatever string I want, which like we'll say it's someone's name. Const name equals Kyle. And there you go. It works exactly the same instead of having to do it the other way. This is just a little bit more cleaner in my opinion. If you're interested in learning more about this string syntax right here, I have a full blog article on it. I'll link it down in the description for you. Now, the final type of really cool formatting that you can do is formatting with the %c symbol. So let's come in here. We're just going to say normal, and we're going to have some green text, and we're going to have some red text. So in order to apply CSS styles to your console log, you can use %c. So by putting %c, it says everything after this %c is going to have CSS styles based on whatever I pass. It works just like that substitution. So I could say my color here is going to be green. Make sure that's a CSS color there. And now when I save, you can see everything after %c has that CSS applied to it. I can do the same thing for red. Let's do %c again. And instead here, what I want to do is I want to change the background color to red. And now when I save, you can see that my text is green here, and here my background color is red. And the way %c works is it goes all the way until the end of my statement or until the next %c. So everything between these %c's has this first style applied. Everything between the red and the end here has the second style applied. And if you had more %c's, it would apply more and more styles. So this is really cool if you want to make a bunch of really cool changes to your console log to make it look exactly like you want, you could do this. And again, this works for other things like console.debug. And if we expose that just by coming in here, you can see it has the same style. And so all those basic logging methods all have the exact same syntax that you can use, which is really handy. Now that's the final of these basic syntax things I want to go through, so we can finally move on to the different formatting based methods. And the first one I want to talk about is one of my favorite, and that's called console.dir or dir. And what this does is it works just like console log, except for the one difference is instead of defaulting to try to print things out in HTML format, it prints them out in like JSON format. So if you print out like a string, it doesn't make any difference because they both print out exactly the same. But if you try to print out an HTML element, for example, document.body, you're going to notice when I expand this, it gives me all of this as if it was a JSON object. I have all these properties and it looks just like an object. Well, if I use console.log and I expand this, you can see it expands it as HTML. So console.log expands things as HTML, while console.error will always expand them as a JSON object. So this is really handy if you need to try to inspect something that normally would be an HTML element. You can use console.error to see the actual properties. For example, if I wanted to see like the children or the value of an input, console.error is the way to go. Now for this next console method, what I need to do is just have an array of objects. Any array of objects, they don't even need to have the same keys. All you need is an array of objects. In this case, we have name, age, and programmer on here. And what we can do is we can just use console.table to print out this array in a format that is much easier to read and parse. As you can see, we have our index on the left, we have all the names, all the ages, and the programmer variables are printed out here. This is a really easy way to try to like look through a small-ish data set to kind of figure out, okay, what do we have going on here for the name? What do we have going on for age? What do we have going on for programmer? We can still expand it the old way if we want, but this table is really nice. You can also sort it if you want. For example, I can sort by age or sort by programmer and sort the other way. This is really handy if you need to like say, oh, what's the oldest person in this array? And you can see, okay, it looks like the age is 72. Just a great way to look at an array in a more pleasing manner. Now this next method is one I didn't even know existed until I started doing my research for this article, and I absolutely love this method. So it's a group of 3 different methods. We have console.group, and as you can see here, we have group collapsed and grouped end. These are the 3 different methods. So by saying console.group, we essentially start a group in our console. So let's just put in some logs. We'll say console.log outside group, and we'll do another console log that says inside group. And let's say, we'll just say like still inside group. And then we can say console.log group, oh, sorry, not log, group end. And we close that off. So now you can see what we have is collapsible section inside of our log. And by default, the name is just console.group, but we can change the name to anything we want. For example, we can put a name here and it gives us that custom name. So we pass a name to this group function, and that's going to start a group with that name. And then everything we log after that is going to be inside that group until we end the group. And now we have this really cool, collapsible section. For example, we could call this like stats. And then we could put all of our different like page load stats in here, and then we could just collapse it down if we don't want to see it. This is super handy. Also, if we call this group collapsed, what that's going to do is just going to collapse the group by default. So if I clear the log and save, you can see the group starts out collapsed, while without that function, you can see the group starts out open. You can also nest groups inside of groups. So for example, I can say console.group, and I could call this one second, for example, and we'll put another log that says inside group 2, and then we'll just end both those groups. And now if I save, you can see we have this second group, which is inside of our stats group. So you can infinitely nest these groups as much as you want, and they're just really handy to be able to kind of group together similar logging things inside your logger so that you can easily see, okay, here's all my stats, and here's all my next thing, and so on. It's really useful if you have a lot of logging going on. Now that's the final formatting-based logger I want to talk about, and the next loggers we're going to talk about are all about performance, and you can break these performance ones into 2 different categories. We have timing-based performance loggers, and then we have profiler-based loggers. So first I'm going to talk about timing because it's much simpler and easier to understand, and probably the more useful of the 2. So just like you have group start and group end, we have timer start and timer end. So you can say console.time. As you can see, we have time and time end. Those are the ones we care about. So when we say console.time, that is starting a timer. And then when we say console.time end, that is ending our timer. And then everything that occurs between there, we're just counting the time. So if you want to see how long a function takes to run, we can use console.time for that. So I can just set up a simple for loop. This for loop is going to do nothing. It's just going to be an example to show time passing. And we can say let I equal 0, I is less than a large number, and then I++. And now if we save that, you can see it took 2.65 milliseconds to execute this for loop that did nothing. It just looped a bunch of times to waste some time so that we could actually see some value here. And the nice thing is this is very precise. By using this timer here, you're able to see down to, like less than a millisecond how long something actually took, which is really good for just fine tuning and doing different benchmarking. Also, you can give your timer names. For example, I can give it a name here, and then as long as I tell it to end the timer with that same name, you can see the name will show up here. And you need to tell it to end a timer given a specific name because you could run multiple timers at the same time. For example, I could start another timer inside of here if I wanted and then end it at a later time if I wanted. So having the ability to end it by name is really important. Another thing that you can do, we just come in here, we can figure out how long our timer has ran without actually ending it. And that's by using the time log method. Give it the same name here, and that will just print out another thing to our console that says how long between when we started our timer to when we log this value, but it doesn't end the timer. So it works just like time end, but instead of ending the timer, it just prints things out to the screen and it just lets it keep going. But time end completely stops the timer and it prints it out to the screen. So this time-based logging is really useful if you want to do different performance checks, but if you want to get a little bit more involved, you can use the profiler. Now, if we want to use the profiler, we just replace time with profile. We can replace time end with profile end. It has the exact same format. And here we replace time with timestamp. So if you want to start the profiler, you just call .profile. If you want to just log out where the profile is at, you can say timestamp. And if you want the profiler to end, you say profile end with the name. And now if we were, for example, to run that, that's going to start and finish our profiler. But what does that do? You don't really see anything. What you need to do is actually go to the profiler. And that's over here in these triple dots. What you can do is scroll down to more tools and you'll see this JavaScript profiler. If you open that up, you can see we have a profiler with that name that we specified of name. We can open that up and you can see all the information about this. Let me just make this full screen for you. You can see that according to this, it took 43.6 milliseconds to run and the entire time was spent inside of this anonymous function. And that's just because we had one function running. We didn't have anything else going on. If you were calling a bunch of different functions and doing a bunch of different things, it'll tell you the breakdown of how long each function takes and like how much CPU time everything is taking. This is a great way to just like put a profiler at the top of your, program and a profiler at the bottom of your program. And you can kind of figure out, okay, where is the bottleneck? What is actually slowing down my code? Because it'll have a large percentage of the time taken up to do that action. Now, the one problem with these methods is they're not actually standard. There's no web standard for these methods. So depending on what browser you use, the way that they're implemented and the way that they work is going to be drastically different. For example, in Firefox, you actually have to disable the modern profiler that they have to go back to the older profiler in order to use these methods. So really, depending on what browser you use, they're going to have drastically different implementations and showcases for what this does, just because it is a non-standard feature, but it works in pretty much any browser you can think of. Now with that out of the way, we've covered all the different performance-laced loggers that we can talk about. So now I wanted to move on to kind of a grab bag of different utility loggers that all do kind of individual things, but are still useful to know. The first one is probably my favorite, and this one is called Assert. So console assert works just like every other console log, like the console log, debug, warn, all those basic loggers, with one exception, is that it takes a Boolean as the first parameter. And it's going to be either true or false. It doesn't matter. You could say like number equals 1 or like 1 equals 0. So this is going to return false. And then we log whatever we want. Doesn't really matter. So you can see here that since 1 does not equal 1, this is false. And to make it clear, I'll just put false here. So if console.assert has false passed as the first parameter, it'll log out to the screen an error. And as you can see here, it says assertion failed, and then it just prints out whatever I put here. But if we pass in true, it doesn't log anything. This is really important because with console assert, we can essentially do the same thing of like wrapping our statement inside of an if. So like if true, then we want to do a console.log, or technically an error. It's really nice being able to do console assert because it allows us to not have to do all this different if stuff. We can just put it inside the console assert and it does it for us. And again, just like our log method, we can pass multiple parameters here and they're going to print out just fine. So everything you could do with normal console log, you can do with console assert. You just pass it that Boolean at the start and it's either going to log it if it needs to, if for example there's an error, or if everything works fine and it returns true, it just doesn't log anything. Now, probably the most useless of all the methods in this video is console.clear. All it does is clear the console. So if we just say console.log here, and then we clear it, you can see that doesn't show up because we cleared the console. Super straightforward, pretty much useless. So we're going to move on here to the next method, which is two methods in one, and it's console.count and count reset. So a count, we can just count the number of times a specific thing has run. So we can just say console.count 4 times, and you can see it's saying default 1, default 2, 3, and 4. And if we want, we could pass in a label here, for example, name. Now let's say we pass in name to these two. Now you can see our name has counted up to 2, and the default with no name has counted up to 2 as well. Let's just get rid of those default ones. What we could also do is reset our count partway through. So we can say count reset. We want to reset that name counter. So now you can see name counts up 1, 2, 3. We reset it here, so then it starts back over at 1. Just a really useful way to see how many times something has run. You can use this count function really straightforward. Now the last method I want to talk about is another really straightforward one, and it is the trace method. All this does is just print out the stack trace. So if I hit save, you can see our stack trace is very small because we have no functions. It's just saying anonymous function, and this is where it's been executed. But if we have a function, let's just call it main. We put our trace inside of here, and then we call main. Now, when you save, you can see, hey, okay, we've called main, and this main was called from this anonymous script. And, we can click script 5, and hey, there's exactly where we called main. Or if we go back to our console, we can click here and say, okay, that's exactly where we did our log. So this is useful if you just want to trace out where you are inside of a function. If you're not really sure how you got somewhere, this is a really great way to be like, okay, how did we get to this function? What led up to this moment? Now, if you enjoyed this video, you're definitely going to love the blog article that accompanies this video. It's going to be linked down in the description below, as well as my entire blog in general. I recommend checking it out. I have over 100 articles on there covering tons of topics that I've never even made videos for. So if you want more learning from me, that is the best place to go. With that said, thank you very much for watching and have a good day.